All right, today. Today's one of those days where it's gonna be fun. And by fun, I mean I'm going to be scrapping all of our collision detection and re-implementing it for at least for our ostrich and vulture collision. So not our platform collision logic, but our ostrich to vulture collision. I want to try to talk through why this is so complicated. So like if these are our two characters, right? Let's say there's a collision, like by the time collision's detected, we're right here, right? So as far as the game's concerned, it doesn't know if all it knows is like, with true AABB collision, all it knows is like, collision, 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 collision. It doesn't tell us anything about, okay, this should be a certain type of collision, because of, like, we can't really do it. Shit. It's hard to explain why this is so tricky, because it's like, if we're colliding, we need to know, hey, this is actually what we're going to call a right collision, right? So we need to split this up. And I think if we make little... Oops. That's not what I want to do. Here. There we go. So I just want half of this. Actually, hold on. What am I trying to say here? So yeah, we need to detect... God dang. We need to detect a... we need to detect different types of collision. And in our platform colliding, we do have left collides, right collides, top collides. We need the same thing for our stuff. Which I know there's a better way to do it than the way I'm doing it, but I don't know what that is. So basically, now I want to say, hey, what if we had sort of like, if we had like a little threshold here, and I want to fill with red for being our top collision, oopsie, and our bottom collision, that's a oopsie. M for marquee, G for paint bucket. Okay. This is the way I'm thinking about implementing it. So like, let's say those two rectangles on our player are actually our top and bottom collision detectors. So we're going to have, you know, and this one is actually going to have the same top and top and bottom. here we go. So if these rectangles are our bounding boxes for our top and bottom collision detecting, let me name this self and this vulture. This music you're listening to, by the way, is coded by me in Sonic Pi here. This is all the code for it. It's really simple. Just doing a live loop of 3 long notes at different fading intervals. And it picks between, picks at random one of these 2 notes. And then playing faster notes with a different synth sound. But yeah. Okay. Okay. So for our, so we're determining these functions in terms of our ostrich. So if there's a top ostrich collision, that would mean that our bottom vulture and our top self ostrich bounding boxes are colliding. So if any of this, right? So this would all trigger a top collision. This would trigger a top collision. All of this would trigger a top collision. So now where this gets muddy is, let's say if we want to also do a side collision detection for this, we could do a slightly different red, but show it in like I'm thinking something like that. But we don't. I was thinking we should go to the middle, but we don't necessarily need to go all the way to the middle. I don't know if that would give us problems, but here. So if this dark red is our side collision and the light red is our bottom top collision, imagine, as far as the game's concerned, these 2 are overlapping, so it depends on what we ask first. But let me get a left and right on our, get a left and right on our vulture real quick. Okay. So yeah, if our boxes look something like this, but our dark red box also goes and includes this light box. I'll explain that in a second, but if we're our vulture here, we would detect a top collision if the bottom vulture bounding box collides with that top one, and we'll check for that first. So like we'll prioritize this, because if this happens, right? Is that a side collision or a top collision or a special use case? We get to decide. But like I'm gonna say, if it's here, it'll trigger a top collision. Instead of a side collision. Because especially since the sprites aren't perfect squares, this should probably trigger just a top collision. And then we say, if the left bounding box of our... How do we do this? This is going to be so complicated. Okay. Because if the right side... Okay, so the way we would test for the different collisions is like we test for a left collides with a right collides of an ostrich, and by right collides I mean the rightmost bounding box of our vulture. We test that AABB wise with our leftmost ostrich, and if that's true, that's a left collision. Then for our right collision, we check the right bounding box of our vulture matched with the left bounding box of our, the right bounding box of our ostrich with the left bounding box of our vulture. And if those two are colliding, you know, all of this up until this would be a side collision. As long as we say that we're determining because we can't determine, we'd have to have some sort of flowchart in our logic execution of these functions. So not in the declaration of them, but when we're actually using them in our update function, we need to say, we basically need to say, if it's top collision, do this. If it's bottom collision, fuck, hold on, let me think. Yeah, we'd have to just figure out what type of collision it is. And we figure out what type of collision it is based on. So I guess we would ask if a top collision is true and ask if a bottom collision is true first. Then if not, then we would say, okay, we'll check the sides. Is it a left collision? Like this. So I think that's the plan I'm going to go to try to fix this. Because right now, our collision for our, look at all our collision, we have just an AABB. And this should actually probably be platform. Yeah. Instead of this saying collidable, we should probably name it platform to be nice, but, and I say that because of this buffer that's built in, and that's for the platform. It's not supposed to trigger a collision if we're, you know, it's not true AABB collision. There's like that's what that buffer is like checking, giving a little bit of leeway on the collision detection on those platforms. Okay. Now, the other thing I want to do is be able to test this collision. So like right now we're testing the collision by just letting the vulture walk into us and then seeing what happens, which I don't, there's a better way to kind of make sure this is working as intended. So I think I'm gonna try to scrap all of the commented out code in our Ostrich class. I think I'm gonna try to remove all of our current vulture player detection, collision detection. I'm gonna remove all that. And then I'm going to, then I'm going to test, I'm going to set a vulture walking left at full speed and me walking right full speed and see how far we align, how far we collide, and make sure we're not past that halfway mark. Because if we are, we would need to do something different for our left and right collision detection. We would have to check DX also at that point, but I'm hoping that's not the case. And if we're still within that halfway up the sprite mark upon the collision when it freezes, then we're good to move on with the next step, which is, I think we're gonna try to, I want to spawn a ostrich, a player instantiation, right in the middle of the screen. And then I want to spawn a vulture right at my mouse's location, so I can do something just like this, where I can have a vulture at my mouse location, I have an ostrich right here, stationary, and then I can move the mouse and I can print out debugging of what type of collision is being detected based on where this is hitting. And then we can test our functions, our collision functions, make sure they're returning the correct values. And then we can go ahead and worry about the implementation of the logic. I was thinking that we were going to need to do a, if we'll have to worry about that when we get to it. But for now, we can worry about those things I just said, and then worry more if needed. So, first is first. Let's take out all code that isn't doing anything in our ostrich. Because when I'm scrolling through the mess of all this code, look at all this commented out code, I'm trying to make sense of the block statements and everything, and it's just driving me crazy. So I'm gonna just clean that out, delete it, and then we can try to do it right, do it better, do it faster. Bro, look at this, guys. This ostrich, 754 lines of code. Vulture, 300. We'll see what this is once we take out all the commented busted parts, but let's go ahead. 20 minutes in, we're finally starting the code. Yeah. Okay. Yeah, I should say that this is a platform instead. We'll leave it for now. It doesn't really bug me, but yeah, let's take out all this crap. Okay. Then we'll keep this self-refresh, and actually we want to turn that on. That's our pausing function upon collision detection, which we do. Where do we do that refresh here? Refresh gets false. Really? I guess it's in our... It must be in our... No, where would it be if it's not here? If self.refresh, it's for the ostrich. So I must be checking for collision. Dude, yeah, where do I do that? Did I just take that part out? I think we need this end in there now because we took out... Oh my god, see what I'm talking about here? Oh my god. Oh god. Here. Wait, no. Yeah, where do we do this refresh? We're not doing this refresh. We're not detecting the refresh. We might be doing it in the play state. Yep. If we collide with Vulture 1, we get the refresh. So that's in our play state. We'll have to remember that. Okay, Ostrich. Let's continue moving our shit. This is all old logic, but basically So where are we doing this? I mean, we're still spawning, right? Oh god. Oh great. Here we go, guys. See, so the thing is, this isn't... It's not self.refresh. This was working though, but this isn't self.refresh. There's no refresh member. There's no refresh member in our play state. We have to say if play state... Did I turn off? Dude, I swear to God, I don't remember turning off the spawning here, but our play state... I don't think I can do that. Oh, maybe I can. Does this mean if we turn this on, we'll start to scroll upwards? I don't remember turning that off. Oh, great. Okay. This is already a nightmare. Yeah, what would this be called? This is play state. So play state dot refresh. Play state dot refresh. Yeah, so if that evaluates to true. Okay. I'll leave this commented out for now. Did we? No, we need this on. We need this on, yeah, because we need to say, if we're spawning, move us up. Then we need to say, if our spawn height is greater than 24, just set it to 24, reset our Y position. If Y is smaller than, then keep moving us upwards. I'm gonna see if we start, if we scroll up now. No, we're still not. Dude, I swear to God, I didn't change anything for that. Did I change? Oh my God, oh my God. Okay. I feel like we need to set this right away. Okay. Okay. Bro, how was this? Let me just look real quick, because this is like really confusing to me. In our last commit, in our ostrich, in our ostrich class, we have return this off if self.refresh. But see, this self.refresh wouldn't have worked. Because refresh is only a variable attached to our play state. It was working yesterday. We were pausing it upon collision, and now we're not doing shit. I'm gonna take this out and see if that fixes anything. If that fixes it, then we know our... Oh, it does fix it. So yeah, we know our refresh wasn't working. PlayState refresh was not being evaluated to true, even though it is true. Okay. I don't get why I had this as self and it wasn't. It was working. Like when it was working, this was titled self? No way. No way. Okay. Yeah, it's busted because self.refresh isn't a value according to the Ostrich class. But we can't say playstate refresh. Why not? It's playstate. We can't say playstate dot refresh. And I'm not sure why. Or, I mean, we can. It just wasn't working. If playstate dot refresh is true, do this. But we are not getting that to work. So, what do we do? Why does this happen? Let me see. I want to see. I want to see this value printed to the screen. What are we printing to the screen currently? Colliding. So we'll turn this off. We'll turn this off. We'll look at where we're rendering this collision. We're doing it. See, we need one place to write this colliding stuff. Right now it's in our Ostrich class, but we're trying to see playstate.refresh, right? We want to see if this is evaluating to true or evaluating to anything. So evaluate that, put it to a string, print it. We'll try to troubleshoot that. Dude, it was working. This was not the thing. Yeah, see, it's not getting set like that. I don't know how to do it. Work. In our update, see, this is where the self-refresh comes in. Okay. Okay. That makes a lot more sense. That makes a lot more sense. So everything in our play state is toggled by this refresh. So we turn off everything in our play state. Yeah, that makes more sense. I should have just deleted it from... Yeah, I need to get more... better about deleting things I know are truly busted, because this could have saved me a lot of time. You know, we don't need any of this. I want to see if I can delete the tabs for everything all at once, but oh god, what did I do? I don't know. It's okay, we'll leave it like this for now. So instead of printing this in our Ostrich, we're going to go to our play state and print out that message with a not play state refresh, but a self refresh, which is technically the same thing. It just doesn't like being called that. Now it'll say true until a collision is detected, at which it'll be false, and then we stop updating. Okay, so that works. Let's keep focused. We'll keep deleting stuff from our Ostrich class. What can we take out? We've got we can redo this logic in our head. I don't really need to screenshot that or anything, but damn, yesterday we did some work, man. We got some stuff going on. Honestly, that shit's just more confusing than anything to me, so we've got an end, an end, an end, an end. Okay. Okay. So yeah, look at all this trash, man. Okay, this is looking much better. Okay. Okay. Holy shit. So look, we're down to 580, not the 700, but that's still the biggest. That's the biggest piece of code I've ever worked on. Oi. Okay. Holy shit. Okay. Like, I kind of want to separate out a couple different parts. Like input handling, that can stay. But the animation cycle can be, you know, just to kind of see it better. So it's like, what is all this? This is all our input handling. Oh, and you know what? I can put, if I put a comment here at 280, one sec. If I put a comment here, go to the end of our input handling, and put in another note bit, I can then leave this on, but close this whole thing. Yeah, so I can say, maybe we put our titles here so that when we, hold on, there we go. Yep. But we also need aerial handling is part of our input handling. Jumping DY. Okay. This is all worth it for the peace of mind, because look, I just toggled off all our input handling and made it that much smaller to look at. And then we can put, here, we can have -- check enemy collision. But this turns off here. Perfect. So I can turn that off. Okay. So okay. This is nice. But we want this come to that. Okay. Now this is platform collision. So we can say cycle through platforms. And leave it on. Cool. How did this is much easier to look at now, but I still want to do a couple more. So it's like if we close our input handling. I'm confused why there's no one of these there. Yeah, we don't want that affecting any code beneath it, so we do need the dash here. I just don't get why why it shows up now. This one doesn't show up. This one doesn't show up, probably because it's on that line, not this line. Okay. Okay. Okay, input handling, then all this animation stuff can also probably be. Is this the one? Okay, whatever. Not gonna lie, the nested blocks are really hard to kind of sift through. But I'm gonna turn this on, put it over here, and then give us a way to toggle it all off. And technically these last two lines probably should go in the same block, but not really feeling it. I feel like I like seeing it there. Because it's not really animation, it's just triggering the death. So we can see it there. So now we've got our animation abstracted away, our input handling abstracted away, our enemy collision, our platform collision. Now, yeah, look at that. So much easier to look at now. What's still confusing though is that some of these, we unnest them, they go all the way. God, it's just confusing. Maybe we just have to be careful if we ever move or indent things differently, because they're kind of tailored in a very specific way. Like the spawning here, or this, for example, this if not self-exploded pairs with this one. Well, okay, well, yeah, whatever. I'll just keep going. Okay. And you know what? I'm gonna put a thing called a note called functions, so that we can just kind of, I didn't like that. If I do just 2, yep. Okay, it's not letting us do this with functions. Which I guess is okay, because we can do this always. But yeah, I guess for now, we'll take our platform collidables down. Okay. Okay. The joys of refactoring, right, guys? I'll look up the definition of refactoring real quick to see if starting from scratch is kind of considered refactoring, or if it's just discipline, restructure existing body of code without changing its external behavior. So I guess we're not really refactoring, because we're actually trying to fix the external behavior in the first place. Once we have the right behavior, refactoring would make it either cleaner or more efficient, or whatever you want to call it. So I guess what we're doing is more so just programming, not really refactoring, because we're actually trying to add features. Let's first of all see if our code still works, or if we bonked something up. Okay. Okay. So I want to try something. That something is to give our vulture a dx of not -1, but whatever our max ostrich speed is. which is 2.35 in the left direction. Okay, so that's as fast as a vulture can run, and I'm gonna run as fast as an ostrich can run into it. That was weird. The first collision actually didn't detect. You guys saw that, yeah. It didn't detect a collision. Why is that happening? It did that time. Hold on. Fuck. Why does it do that? That's cool. So, I mean, the thing is, it shouldn't register us being exploded because we don't get exploded until a collision's detected, and we don't freeze until a collision's detected. But I guess if we're updating our ostrich before we're freezing, that would make sense. So we're checking that. So if the first thing we check, where is this? Player 1.update. So right now we're doing after the player's updated, then we're gonna set refresh to false, but maybe we'll. I'm curious. Oh, no. Hold on. I'm curious if we take this stuff and put it kind of first. Let's see if that changes any of that behavior, because we want to just detect a collision right away. Okay, I'm still confused why we're turned, but that did stop us. I don't think we're gonna run into the problem. See, look at that. Do you see his joust? Our vulture's joust is going into us, but I don't think it's past halfway. I feel like halfway is right here. So at its max speed and our max speed, it doesn't pass half. So our left collision detection, if we set it to be half of our player and ostriches and vultures width, we should be fine on all counts of the collision detection, because that test passes. I'm hoping, because it's like, I guess it depends on where the middle really is. I'm hoping the middle is right in between his eyes. If it is, we should be good. I'm just gonna see on hold on, I'm still kind of curious. I don't want the vulture to update if we are refreshing. Which I don't think it will be. Well, it's hard to say. That's, I'm curious about this, about where the halfway mark is. So that is 16 wide, so 8 pixels in is our half, right? it's looking like it's right. Yeah, the halfway mark is right in front of our eyes. So if it goes past our eyes, it might not work. See, why does that happen? Why would... Because if the collision's detected, like we bounced... So what's happening? Yeah, that should freeze us. Okay. Okay. Let me see. First, hold on. Let me see if we can... See, I'm trying to see... We need to be facing right. They need to be facing left. It doesn't look like it goes past our eyes, but it's real close. I think we'll be okay. But I'm not so hot on the... Why would it be bouncing us? It's bouncing us without freezing, you know? But we're bouncing, or we're freezing upon collision detection. So I think we might need... Okay. Yeah. Okay. I think I know the problem. You know, we're seeing if... We're detecting if player 1 collides with our vulture. And if it is, keep rendering. If it isn't... No, if it is colliding, stop rendering, actually. Yeah. Refresh gets false, stop refreshing it, freeze it. I guess we should call it freeze. We're asking for the collision detection, but in our update function here, we move the vulture so it doesn't collide. So we would have to actually put this value. God damn it. This is too much. Like, I want a global variable that's not a constant. So I'm gonna say not a self.refresh, but a freeze in all caps. And the freeze in all caps is like a... I guess we don't need it in all caps. All caps would be a constant notation, but we're just wanting a global variable. By default, every variable's global. You know what? They say that, but there's plenty of times I've seen where it doesn't. But I think... I wonder if I can say this. So if freeze gets false upon start, freeze gets true upon collision. See, and this doesn't quite fix our problem just yet. We need to put this into our player. You know, I think this is kind of pointless because we've already frozen it, or we've already paused it to solve our problem. This is just kind of like an idea I had, but we don't need to do this. Because the thing is, I was trying to see if we could modify a global variable. That way we can change this refresh to become false over here in the Ostrich class. Then in the Ostrich class, it sees if... But yeah, it's the same problem because in the Ostrich class, we'd have to also do a similar, we'd have to also pause the Ostrich update in the Ostrich class if we didn't want our ostriches to move before we officially freeze. So refresh gets true. If we collide, refresh gets false. That sounds right. And then we, yeah. Let me just see if that works, I guess. Okay. See, look at that. It's like 1 pixel. I think that's like... Okay, that might be... I don't like how close that is. Because if the... So that means the vulture's coming in, and by the time the collision's detected... Actually, not necessarily, well... Yeah, I guess it would be... It's not really by the time the collision's detected. It's actually if there's a current collision. Yeah, actually, okay. So we can test. What was screwing us up is that we were resetting. So look, if we find our enemy collisions and we just don't do anything. There's a better way of doing this. See, we're asking if we collide here, but we're asking if we collide in our play state. So instead of doing the logic, we actually want to just not do the logic, and then it'll freeze whenever the collision's detected. Perfect. Okay. I'm okay with that. Let's test it again. So close, but I think that's okay. I think it's okay. And then this, it should freeze as soon as it walks into us where it wasn't before, but yeah. So that detects the collision right away. But if we're moving faster, it gets closer and closer to us. Okay, I think we're gonna be okay. I'm trying to decide if we need a little gap in the middle or not, like this. Because if we do have that gap, then if we're past the middle, it won't trigger a left. You know, if this gap, god dang it, yeah, we need this same exact gap in the other one, but. So this would be a left collision. But then, you know, this would be the joust right up to our eyeball, which it was. If we're checking a collision for this, if there's 1 pixel over, this would trigger a left detection and a right detection. Or no, it wouldn't. It would just trigger a left detection. So we should be good. Right detection can only be true if these two are hitting. Those two are hitting. These two are hitting. These two are hitting. You guys can kind of see that, right? And then we'll just prioritize the bottom and top collisions. So if we're right here, this is still just a bottom collision. And we might have to tweak this a bit depending on our jumping. Because if we're jumping so high that by the time delta time elapses, we're up here, it would trigger us a left collision, therefore bouncing us this way. But we actually came from the bottom, so we're going to test the jumping and make sure we don't get any too weird stuff. But since the top collision is actually, or this is our ostrich, the bottom collision will actually just kill us if a bottom collision is detected. So maybe we do a, no, shoot, I don't know what to do. We'll try it. So right now we have the enemy collision logic off. We've deleted a bunch of our old nasty stuff. We've collapsed a bunch of our stuff to see. So now's a question. Do we need a true enemy collide bounding box? Or do we not? I think we need to just check which type of collision it is. And as long as we're robust about implementing that, we shouldn't need this true collision, because the true collision doesn't help us. We really need the specialized collision to know what the heck to do in certain scenarios, because the true collision doesn't really help us in this game. In this instance, you know, with an ostrich versus a vulture. So I'm going to see any instance of using this collides. So and it's not the bottom collides or left collides or right collides, it's just collides. So it's right there, and that's it. Okay. So I feel safe in taking that out. And it's like, do we want to keep this as a true AABB just in case? Maybe. I don't know. Let's do this. We're going to give ourselves a function for our ostrich class called enemy. Let's do what's the way to do it? We'll do top and bottom and left and right. So enemy top collides. That takes in an enemy parameter. Will give us, we'll do top, bottom, and then we'll do left and right. So enemy left collides means the right side of the enemy hits the left side of our ostrich. And then enemy bottom collides means an enemy's top hits our ostrich's bottom. Cool, those are our new functions. Now we need to give them real stuff. So, we are, let's give us a new layer real quick. We're function, come on, here, 2, black. You know, That's awful. We need to segment this. Then we need to segment this. Right, so if we're if we determine our bounding box based on our object's width and height, which we should because those are variable, then we'll have accurate collisions based on if one's in the air, one's grounded, they're both grounded, both in the air, all that sort of good stuff. So we'll make sure to do that. So this will actually be... Let me take a look. Are we 16 by 16 if we're aerial? It is 24. Height is 16. Okay. So if this is 16 by 16 pixels, how many pixels do we want this red to be? Let me give us a square 16 by 16. Whatever, 17 by 17, close enough. Now we're gonna see. Yeah, about that much, right? Maybe a little less than that. So 2 pixels. Okay, so 2 pixels will be our height. 2 pixels. Okay, that's easy enough. So it's just half, and then 2 from the bottom, 2 on the top. That should be easy. So, in our functions for our Ostrich class, let's do our top first. How do we determine a top collision? Well, the Ostrich top collides with the vulture bottom. So what does that look like? We can say, for whatever reason, I like doing the false, the AABB collision, doing it false instead of for true. It's just easier for me to imagine it. So I guess we'll try this. So we're gonna say if the left side of our ostrich is greater than the right of our enemy, or so that's our left side is to the right of the enemy, or if our left side, actually, yeah, our right side, or if our right side is to the, to the left of our enemy. Or if the top part, so yeah, on the x-axis we want to check the whole width, but on our y-axis we want to check only the top 2 pixels. So we're going to say the top of our ostrich is greater than our vulture's x, no, our vulture's y, I mean, it would be enemy y. If our y is bigger than the enemy y plus the 2 pixels buffer, or if the bottom of our image is smaller than the top of our enemy. And if all those conditions, if any of those conditions are true, we know we cannot have a collision. Otherwise, return a collision. Okay, so I want to test this real quick before I write all the functions. Let's just test it. Make sure top collision's working. Okay. So yeah, we need to let me look something up. Check that out. So we could do something like this. Love.mouse.get position. Then draw the image at the mouse position. So I want, okay, so here's what we're gonna do. We're gonna give ourselves I don't know how to do this. We're going to give ourselves a mouse ostrich that we're going to instantiate. Shoot, man. I don't know if this will work. We want a stationary ostrich right in the center. So we'll do its x position is going to be virtual width divided by 2, virtual width divided by 2, and then moved to the left 1/2 of self.width. That's our x, and our y is virtual height divided by 2, shifted up by half of our self.height. So we're right in the middle of the screen there. But the thing is, we need to update this position. No, we need to update this position at the end of every ostrich update so that we don't accidentally put it somewhere it doesn't belong. So we're going to say this X is set to our middle of the screen and our Y is set to the middle of the screen. I don't know if this will work, but I'm hoping it will. I'm going to set in our play state our X for our mouse ostrich. I don't know if this will work. I don't know if I can define it in terms of self, because this self.width is actually this parameter here. I don't know if I can do that, but we'll see. So this is our X we're trying to reset it to. We just want it right in the middle and it doesn't move. That's what we want for this ostrich. Okay, and then we need to, we are rendering it. Oh, give me a break, dude. Function at line 98 needs to be closed. Okay, let's see. Yep, we couldn't do it. Okay. But we'll just hard code in the instantiation parameters or arguments, and then if our width, width is this and height is this, so we can just hard code it in. Let's try that. So we are not updating here. We're not updating our ostrich or rendering it actually. Since we only had one. Where is our ostrich render? Here. So we'll add a mouse ostrich update. It gets passed in delta time of the current frame. It will also give us a render of that mouse ostrich. Now, we're hoping to see another ostrich right in the center. This is exactly what I was terrified about. Okay, I'll tell you what. Right here, in our ostrich, when we update our mouse, we need to update everything to just be nothing, right? So like we need to say, hey, our height is 24. Our facing right is true. actually, we don't need to update. Actually, yeah, we don't need to update this shit. We just need it there. Oh, we do need to update it because we need to check. We're going to be checking if we're colliding, so we do need to update it eventually. Let me see if that fixes anything. We're still fucking goddamn it. Why would that change us? You know, we would say mouse.ostrich.grounded is true. Mouse ostrich should have no effect on player ostrich. Which makes me not very happy. Okay. What the shit, man? You know what? We don't need mouse ostrich. We need a mouse vulture. We'll just leave our ostrich. Yeah. We won't do... We will not do a mouse ostrich render. And we won't do a mouse render ostrich update. We'll just have the player one. Now we'll need, instead of doing this mouse ostrich, let's do mouse vulture. Okay. Now the thing is, I don't want... a couple things. I want our speed to be slower again, instead of our max speed. Where's our DX? Didn't we... Oh, vulture DX. Yep, we're just doing -1 instead of max speed. And then, yeah, we're looking for mouse vulture. Gets a vulture instantiation in the middle of the screen. I want our first vulture here. Where are our other vulture here? Instead of... Yeah, look at this. So we'll say... Okay. Instead of mouse vulture... Okay, so this is a little... The way it's set up is we're rendering it and updating it through the vulture table. So we just need to put our mouse vulture in our vulture table, and then we'll take off the current vulture, just like this, and then we'll insert our new vulture into our, we'll insert, you know, our mouse vulture into our vulture table. So we'll say table.insert. And we're inserting into our vultures table, and the thing we're inserting is a vulture instantiation with all those things. And then now our vultures 1 will be our mouse vulture, but we gotta change that now. So we gotta say, fuck. It's almost like we need a totally new class, you know? Because we're going to be doing... we want the X and Y to be bound to the mouse position, not have anything to do with the vulture position. So... Fucking goddamn it. Because if we want our vulture to now have X tethered to... Actually, let's try it. Yeah, let's just try it. We'll go to our vulture. We'll say, hey, After all your update, it's nice that you did that. I appreciate it. And by the way, give us a local variable called mousex and mousey, two local variables, and we're assigning that to we're assigning the value of love dot mouse dot get position. No, love dot mouse. What was that, guys? Get position. Get lowercase. Get that. Okay. Get position. Now we are going to update. Let's see, how do we do that? Yeah, we would say vultures 1. Our vulture's first index, its x, now gets the mouse x, where our vulture y now gets our mouse y. So since we're doing it at the end of the update function here, the idea is it'll update, do all its thing, and then it'll be like, by the way, I'm just setting your x and y to your freaking mouse position, by the way. But I also, actually, it's hard to say if I should take out any DX updates, but it'll just set it to our mouse position anyway, so maybe be okay. Let's try. Platform spawn, vulture 99. Why does that all of a sudden mess up? Why? Platform spawn, a number value, attempt to index. Oh, we need a platform spawn for our vulture. So if this is our x, y, width, height, platform spawn, which platform spawn in our vulture class just gets assigned. So platform spawn, is that just an x position? Or y position? It's a y. I think it's just a y position. We are giving it there though, so why does that shit break all of a sudden, you know? This is wrong. We're doing a dot platform spawn dot y, but this doesn't have a dot y. We can call this platform spawn y, and platform spawn is our parameter. Platform spawn y gets to be assigned to the argument that it gets passed in. Then our platform spawn y is actually just this. Let's try that. Okay. Curious if we take this out, if the vulture even shows up. It does. We need our vulture. Yeah, we need our vulture to spawn at our vulture platform 3, I think. Okay. That's why. Fuck. No, yeah, we can do a dot y. We do a dot y there. It's just a y value. You know what? Let me give this. So we're seeing him, but when we're going to change its x position, and we can actually say self.x and self.y gets the appropriate mouse positions. Oh, x and y. Well, okay. So instead of changing our x, we're actually just gonna draw it. Well, see, because what this is doing is just drawing the image at our mouse location, but we want to actually move our whole vulture object when we move this, as well as drawing the image. So we can't just say that. Here, love.mouse.getx.getY. Yeah, let's just do that instead, because I think that's going to be better. So mouse x gets love.mouse.getx. And mouse y gets love.mouse.getY. Okay. Now, I just want to print out. See, and this says local. I don't know if it means local to this function or local to this whole, whatever you call it, class. I'm going to try to just say here, let's do actually, we already did that, so we can just set the font. Okay. We can print out. What do we want to print out? We want to print out saying mouse x. Concatenate that with a stringified version of our mouse.x. We want to print that at 5x, 10y. Let us see if mouse x is getting updated. It is nil. It is nil. So what happens if we say love.mouse.getX? Really? Let's... Oh, it's not a function, it's just... Oh yeah, you do have to do it. Get x. X. maybe if we don't do local, then this mouse X can be read by the render function, maybe? I just want an X. There we go. Cool. So let's turn off this for now. Let's give us a mouse Y. Debug. Okay. Print out mouse Y here. 5 pixels lower. And now we should have an X and Y for our mouse. How about another 5 pixels lower? Cool. So 0, 0. Okay, we've got the freezing on still, which we should probably take off for now. Our freezing's in our place state. Let's call this refresh. We don't do the refresh. We just need to take this out. Then also, there's a line. We're just not going to be doing that refresh. Let's see. Now we shouldn't do anything if we collide. Okay, cool. Eat my butt. Okay. Okay. So now instead of, like, now can we, at the end of this, say, hey, your X is actually mouse's X. And you know what? Your Y is Y. And then we're drawing at our current X and current Y, which should be the X and Y positions that we got from the mouse. So now I'm hoping we'll draw the vulture right at our mouse location. And we're not. Let us also print out. So look, we want this and this. And we want to say, hey, by the way, also give me vulture X, vulture Y. Okay. And give that your current X and your current Y, which I'm hoping these two values, the vulture X and vulture Y, are going to be matched to the mouse because we're copying it into there, but this is why we're debugging to see if it's working. Yep. Okay. It is working. What if we... Why is it doing this? Why would it not draw it? You know, it's almost like we need to also say, like, hey, self dot let me just see this. What if we were grounded? What if we're facing left? does that change anything? Does that show us the ostrich now? Did you see it for a second? Oh. Dude. This is exactly the shit I want to test. Okay. So, I don't know how to fix this, but our mouse, like look at here. Yeah, I toggled on our mouse so you can see it. The rightmost side of the screen is here. The bottom of the screen is here. So it's a square, you know, about this far. And that's because this square is the original, is the actual resolution our virtual resolution. Because if you see, yeah, when our x becomes 292, that's about our virtual width, and our virtual height is about 230 or whatever it is, 230 and 280 or whatever. If we look here, yeah, 240, 292. Okay, well, it is working. Cool. That's really cool. So, you know, I think I need to set its dx to 0 as well. I don't get why it's showing us the aerial sprite instead of the grounded sprite. But if I swap it, I'm wondering if that'll change anything. It doesn't. It stops us from walking when we're there. So yeah, this is what we can use to test our collision hitboxes now. That's so sick. Okay, so yeah, that's backwards. It's like we just don't fuck with our grounded position. Because it's like all that shit's still calculating, it just can't move. See, because this should be grounded, right? Yeah, if we're right there, we're grounded. But if we're up in the air, we're flying, flapping. Okay. This is okay. This is good enough to test. This is sick. This is so cool. I'm so thrilled with this. This is so much fun. This is so cool. We're not getting the sounds that we used to be getting. Are we? Oh yeah, we used to be colliding and hearing it, right? I don't know why that stopped. Okay, I know why it stopped. We took our DX to 0. That's why. See how we're walking there? Because our DX... Okay, that's okay. We don't need that on. I think it's okay if we have our DX be 0. Remember, we have our DX 0 not triggering any collision platforms, so people can't just fly in the buffer zone of the platform and have it trigger infinite collision sounds just like we're seeing. So that's why we implemented. Jeez, guys. I'm getting fried. It's been an hour 45. You guys, we keep going. We're making progress finally. Okay. We are updating our vulture's position to be... Okay, here. I got an idea. Just what we were going to do, right? So under our Ostrich class, we're saying there is a function called enemy top collides. And it takes in a parameter of an enemy that has an X, a width, a Y, and a height, but actually it doesn't need a height because we're actually doing the hard-coded 2 pixels height for that top collision detection that we determined right here, that 2 pixels right here. And our top collision is actually right here on our Ostrich. This is our Ostrich, and if this is our vulture, this box of our vulture needs to collide with this box of our vulture in order to detect a top collision. And that's why we want to be able to place our vulture so that we don't drive ourselves crazy trying to have a vulture land on our heads in order to just test this functionality. So this will return true. I'm hoping I did this right. We'll have to, this is what we're going to print it for. So I'm going to say in our play state. So look here, let's turn off. We'll turn off the rendering for our mouse stuff so that we can easily just kind of paste our debugging for our printout in our play state of our collision between our Ostrich and our vulture. So we'll say top collision. What we're printing there is a result of our function that we're running on our player 1 object, and it's called enemy top collides, and it takes in an enemy, and our enemy is the vulture at index 1, which is the only vulture, but it's the one that's updating with our mouse position. So it should be false upon loading. Yes. We still need to turn off our vulture's X and mouse Y. I thought we did that. Bro, yeah, we just turned it off. Did we put that in a different... That was weird. I didn't do anything different. Maybe I just saved it. There we go. What am I doing? Okay. Here we go. Top collision false. Ostrich 100. Attempt to compare number with table. Enemy top collides number with table. Okay. Okay. So this, it didn't like... Wait. Line 100. Okay, so it didn't like the parameter we gave it. It didn't like this. So we put in our vulture, shit, how do we mention it then? Because we don't even have a name for it. It would just, oh, no, yeah, in our vultures table. And we're doing vultures table. It's Lua is one indexed, I know that, so. As soon as we detect any collision, it gets wonk. Enemy top collides. Attempt to compare number with table. This is the table it's talking about. But it doesn't. Oh. Actually, wait. Oh, yeah, we're converting it to a string. Player 1 is our ostrich. Vulture at 1. I don't see why this wouldn't work. I don't have a name to index this, but I guess if we just go here and go into insert, like, can we say here this is mouse vulture? Oh, you know what? We need this right beforehand. We need this to be saved as our mouse vulture. Say mouse vulture gets this instantiation. Then we say insert into our vultures table this mouse vulture instantiation. Now we can say here that this collides with not vultures 1 but mouse vulture. Now let's see if it yells at us. Really doesn't like that, does it? What is it not liking exactly? Enemy top collides. It doesn't like that. It doesn't like the parameter that we're giving it. And I think it might be because we are not I think instead of our play state, if we try to print this up in our ostrich. Oopsie. Oopsie. Dude. What? I'm gonna take this, paste it in our ostrich render. Why not in our vulture render? I don't know. Okay. We're just taking this. Okay. We're going to print our collision to our player 1 and we top collides with self. Can we do that? With this ostrich. Play state 20. Really doesn't like that. Why is it crash though? Sorry guys, I thought we were gonna be able to fucking figure this out today. I'm just not figuring it out, man. My reasoning for moving it into the vulture class is because we need the proper X positions, but actually we're printing this. Actually, yeah. I guess it kind of makes sense. Wait, no. Top lines. I'm curious if this does get set true if we're in the right spot. No. Fuck. Shit. So it's like, what if we just say, you know, we didn't delete our enemy collides function? Did we not? Or did we? That's in Ostrich. We have a true enemy top. Oh, wait, hold on. Ostrich top collides. Oh, yeah, we have that. Ostrich top collides. Okay. So, what I'm wanting to see is if we can run the true enemy collision, because we have a Ostrich collides. That should be true axis aligned bounding boxes. So we'll say it's just collides. And we'll put self. I don't know if I can do self there, but we'll see. Okay. So look, this seems to be working for the true collision, right? And it's not crashing when I move down here like the other one was. Oh, and you know what? I think our mouse positions are screwing shit up. Well, no, because I'm moving it all over the place and it seems to be fine. Okay, well, we've got true collision working. True AABB collision detection working. But we don't want to do that. We want to do enemy top collides itself. Let's check out our code here. So our code for it is in our Ostrich. We're saying you know, I'm saying all the ways a collision would be false, which would be if our left side of the object is on the right side of the rightmost side of our enemy, impossible to collide. If the right side of our ostrich is to the left of the left side of our enemy, impossible to collide. And then we're saying if our y is greater than the enemy's y plus 2, and let's just make this like plus 8 for now. If y is greater than the y plus 8, that'll also be an impossible collision. Or if the bottom of our ostrich is smaller than, oh, here's a problem, enemies.y. Let's put the 2 back in just to see if that's literally all that was messing it up. Here is now top collision. And it's not exactly working right. See, we don't want true here. Let me make sure we're actually running the top collision. Oh my god, okay. We want to make sure that we're actually printing out our top collides. Yeah, not our true collides. Okay. So we just fucked up this. We just fucked up the thing here. Let's do this again. It's hard for me to imagine how to do the true collision, but let's give it a shot. So like, we know it's a true collision if our ostrich's x is greater than I don't know how to do this. How do we know there's a collision? It's like, oh, we need to return true if whatever the fuck returns a collision. What do we say? Let me try to draw this out real quick. So it's like this way we would say there, oh, there, there. So this is like, god dang. If our x, no, yeah, we want to see if how do we do this? Sorry guys, I'm just like, I don't get it. How do we know it's a collision? Well, if the left side of our ostrich is smaller than the right side of our enemy, if the left side of our ostrich is smaller than the right side and our right side is greater than our enemy's x, and here's where we need to do the special y, right? So we need to say we would be colliding if the bottom part of our ostrich. Okay, I think I'm realizing what we messed up. Because yeah, we're not checking. Well, no, actually I don't. Yeah, this should be -2 or something. Okay. Let me see. And this one's fine. It's the top collide that I fucked up with the y. So we know it's a collision if the. Let's start with the top of our ostrich. So we'll say our top would have to be smaller than the enemy's top plus those 2 pixels. But I'm going to give us a buffer of like 8 for now. So if ry is smaller than the enemy y plus 8 and our, so that's the top of us is smaller than the bottom part of the enemy colliding box, and the bottom of us plus our height, and the bottom of us would be bigger than our enemy's y. We don't need to put a +2 here because we just need to make sure that we are, I mean, the and will cover that it's not too big. So our bottom can't be bigger. Or no. The bottom of us is bigger than... See, and this isn't right. No, this is... This would be the 8. We would say, and if the bottom... No, hold on. This wouldn't be. Because this is the top of our ostrich. Seeing to see if the top of our ostrich is smaller than the bottom of that bounding box, and the bottom of our ostrich's bounding box is greater than the top of theirs. Okay, I think that's right. If all those things are true, then return true on that collision. Else return false. So let's see if that fixes us. And gotcha. Let's see if that fixes us. So we're looking for top collision true. It is not until we get down there. So this is tricky because see, this shouldn't be the case. It's only true if they're small. See, this shouldn't be a top collision. Because our top collision can only happen if our bottom of our... God damn it. Okay. Let me try another tactic. It's hard for me to wrap my head around how to write this function, but it's clearly not working. It's like not turning out how I expected it in my brain. I'm gonna make bounding box visuals for my ostrich and my vulture. And we know the top is 2 pixels. So as far as top collision is concerned, we're only checking the ostrich top bounding box and the vulture's bottom bounding box. So if we plot out the we would need to say, god damn. Okay, so let's look at our code here. Inner ostrich, top collides. We're seeing if the top of our ostrich is smaller than... This is already... Okay, no. X. The left side of our ostrich is smaller than the right side of our enemy. If it's smaller than... The left side of our ostrich is smaller than the right side of the enemy, and the right side of our ostrich is bigger than the left side of the enemy, then at least our x's are aligned. We know our x's are colliding, but we need to make sure our y's are colliding. So then we say, and the top of our ostrich must be smaller than... No, see, this isn't right. This would be... The top of our ostrich would be smaller than the vulture's bottom. So this is actually not where we need the +8. This is actually where we need the enemy height, because we need the bottom of the bottom bounding box of our vulture, and our self y +8, the bottom of our. Okay, let me self y, top of our ostrich would need to be smaller than the bottom of our vulture, and the bottom of our bounding box would need to be bigger. What is that? Okay, for the y's, we know we're x colliding, but now we need to check for our y colliding. So we're going to make sure the top of our ostrich is smaller than the bottom of our enemy, but then we're going to make sure the bottom of our bounding box, which is this, the bottom of our bounding box will have to be sorry, it's so hard to think about this. The top of ours would need to be smaller than the bottom of this. Top of this would need to be smaller than the bottom of this. But then the top needs to be, what do we even say? And the bottom of our ostrich needs to be bigger. Needs to be bigger than. Okay, top of our ostrich needs to be bigger than, not enemy y, but needs to be bigger than the enemy y plus the enemy height and I think we do subtract 8 here. I'm not exactly sure, because we would check that the bottom of our bounding box is, hold on, sorry, I need to draw this out. Our y is smaller than the enemy's y plus the height, so our y is above the bottom of our enemy. So it's like, hey, we're making sure we're above the enemy, so like hold on. No. Self.y is smaller than this point, the bottom point of our vulture. So if we're making sure our y is smaller than this point, our y is smaller. Yeah. So our y would need to be smaller than that point. But then the bottom of our ostrich box needs to be bigger. Bottom of our ostrich box. Bottom of our ostrich bounding box will be why is this so hard to think about? Okay. Let me think. See, imagine trying to debug this when I would need a vulture to land on my head to see if it detects the collision or not, So I'm really glad we implemented that thing. Oh my god, okay. So we're trying to see if the top of our item is smaller than the bottom, and our bottom is bigger than the top. So yeah, we do need the -8. We do need the -8. And we'll leave it in at 8. We'll see it And hopefully it's working better. Dude, so look. Top colliding, true, right? We're down here, no top collision. Colliding with the bottom of the ostrich doesn't count as a collision. But see, look, this shouldn't trigger a collision. This is because the +8. We just need a +2. So I think we're actually good on this. Okay. So look, triggering a top collision. True. Yep. We just want that sliver. So see how it turns false when we go past a certain point? We might need like one more pixel. But I don't exactly know. Because the thing is, if we're here, is this a top collision or side collision? What the heck? That was strange. So look, this triggers a top collision. Isn't that crazy? Now we might want to... You know, it's like we don't want to fuck with the X, because then... Okay, so yeah. So basically, this should trigger a top collision, because if we're hit like this, not only is the lance higher, so we should turn into an egg, but yeah, it just makes sense that that would be a true top collision. I think we need more than 2 pixels, actually. I'm gonna put 4, and then we'll lower it if we're getting weird stuff, because that offset makes our bounding box for the top collision detection bigger. So even this, yeah, this would trigger a top collision now too, which I guess it makes sense, right? Because like if the ostrich is coming this way, right here, we're dead. As far as the bounding boxes is concerned, this is so cool. I love this. Cool. We've got top collision working, homies. Let's do a quick git commit here before I lose too much progress. We're gonna commit and add with a message saying kind of feeling a little roll, so we're gonna see if we can figure out our corresponding bottom collides, which actually is the same exact shit, just swapped self and enemies, right? Because it's the same bounding box, we're the same type of squares, so we actually just need to swap all of this, right? Enemy, self. This is wrong. We just need to swap. No, we need to change it. Fuck. Because yeah, our bounding box. Yeah. Okay, we'll just do it. Okay, here we go. Ostrich, enemy bottom collides with enemy function. What do we do? Let's first check our X position. we're going to make sure the top of our ostrich is smaller than... Actually, yeah, for the X, we don't need to do the Y offset, so this is just standard boilerplate AABB collision code. So we're seeing if our X is smaller than the right side of our enemy, and we also need to see if the right side of our ostrich is bigger than the left side of our enemy. Then we need to check if the top of our ostrich is smaller than the bottom. No. We're trying to see if the bottom of our ostrich. Yeah, we're trying to see if the bottom of our ostrich, self.y plus self.height. The bottom of our ostrich has to be smaller than. Yeah, bottom of our ostrich has to be smaller than the bottom. Yep. Smaller than the bottom of our enemy. And that the bottom of our self-y plus self.height. The bottom of our ostrich will have to be bigger than... No, hold on. The last one here we need... Fuck. So we check the X, then we say, hey, is the bottom of our ostrich smaller than the bottom of the enemy, and the top of our bounding box greater than bottom of our bottom of our bounding box smaller than this is where we need the fuck, hold on. So hard to think about. But yeah, we need, so yeah, if we need the bottom with the top, right? These two kind of cross, so it's like the bottom of our ostrich needs to be bigger. The bottom needs to be bigger than our vulture's top. So we need to say the bottom of our vulture needs to be bigger than the top of this. It needs to be bigger than the top. That means that if our bottom is bigger than the top part, but smaller than the bottom part. So like the bottom of us, not actually the bottom of us, the, shit. The bottom of us needs to be bigger than, bottom of us needs to be bigger than vulture's Y, and vulture's, and the top of us, or the top of our bottom bounding box needs to be smaller than the top. Smaller than the top. This is very tricky. So we're saying the bottom of our ostrich is bigger than enemy's Y, but the bottom of our ostrich and the bottom of our ostrich minus the 4, bottom of our ostrich 4 up, needs to be smaller. That needs to be smaller than the top of our vulture X. Enemy X. Then if that's actually enemy Y. Then if that's true, all those things are true, then return true. Return true. Else, return false. Don't forget your end. Now, I don't have much faith that that'll work. Mainly because I'm offsetting by 4 on both of these. So I need to see if the... No, I think that's okay. Fuck, I don't know. I'll have to like really think about that. Or, I mean, now's the freaking time. So, we're not only gonna print our... Where do we do it, man? Yeah, we're gonna print bottom collision, enemy, bottom collides. Bottom collides with self. Let's see. That triggers a bottom collision. See, this should be true. That should be... Gosh, I feel like we might need more than that, 4 pixels even. But yeah, true up here. Do we change it to 4 or 8? We have it just 4. Okay, well, it's looking like it's working. It's looking like I did it right. Yeah, top collision, bottom collision. Yeah, and then these will have to be, you know, left collision and right collision appropriately. Top, bottom. So yeah, now we can do specific things according to these specific collisions, which has been the whole problem these past 3 episodes. Let's see if we can knock out our side collides. So if we have a left collide with our ostrich, we know our left ostrich bounding box and our right vulture bounding box would be colliding. So if we want to do AABB collision for this, we're going to check if the left side of our ostrich is smaller than the right side of our vulture. Hold on. left side, I think that needs to be greater than, actually. Hold on. Good ostrich. Okay. So yeah, we need to make sure our left side of the ostrich is bigger than the middle way of our vulture. So Rx would need to be bigger than the end of the ostrich. We could either do what our ostriches are, how many wide? 16? So 6 Rx would need to be bigger than let me think of this. Okay, yeah, I think that we have that right. So we need to say enemy X the left side of our ostrich is bigger than the enemy X plus half its width, and the right side of our ostrich, which would be, it would actually be the right side of our ostrich bounding box, which is that. The right side of that needs to be, if Rx needs to be bigger than that one. No, hold on, this is wrong. Yeah. Yeah, actually. Okay, so this is actually a little different. We need to be, Rx needs to be why is this so hard for me to think of? So yeah. Our ostrich X needs to be bigger than the middle of the vulture. And the right side of our ostrich needs to be smaller than the left side of our enemy needs to be greater than. And the right side of our ostrich needs to be smaller than. No. I don't know why this is so confusing to me. So we need to see if the left side needs to be bigger than the left side. The right side needs to be smaller than the right side. So the left side needs to be bigger than the left side. Yep. And the right side. And the right side, yep, which is self plus 8, needs to be. Why is this so confusing to me? Our left side needs to be bigger than So the left side would need to be smaller than the right side, and the right side would need to be bigger than the left side for collision. So we're saying the left side is bigger than the left side, and the right side is smaller than the right side, which would be just our vulture, our enemy, dot x plus its width. Okay. There's the x collisions. Now we check the y, and we're going to see if the top of our ostrich is smaller than the bottom. Okay, so this one should be easy, because self y needs to be smaller than the enemy dot y plus height of our enemy. Then the top of ours needs to be smaller than the bottom, and the bottom of ours needs to be bigger than the top, which is enemy dot y. And we don't need the buffer there because they're full sized. So now we should get some times where we're returning more than one collision, which is okay. I'm just gonna see if this left collides works. So we're gonna print out we just did enemy left collides. Let's give it a shot. Okay. We're going for left collision here. Nope. I feel like the bottom collision isn't as sensitive as the top collision for some reason, but we're not getting any left collision, so we're doing something massively wrong. Okay, well, we're seeing if the left side of our ostrich bounding box is bigger. Oh, actually, yeah, this needs to be smaller. Wait. No. Yeah, we need to see if our left is... What? What? Hold on. Okay, so we're trying to see if the left side of our object is smaller than the right side of our bounding box. So yeah, we need to see this is smaller. The left side of our ostrich is smaller than the right side of our vulture, which this is actually wrong. We need to see if the left side of our ostrich is smaller than the right side of our vulture. Yeah, this would need to be smaller than the right side of our vulture. Smaller than, so this needs to be, this actually needs to be enemy plus width. X plus width. So the left side of our ostrich, we're going to ensure that that is smaller than the right side of our vulture, and that the right side of our bounding box on our ostrich is bigger than the bounding box of our vulture. So this is where we need the 8. And the top of our ostrich, we're going to make sure it's smaller than the bottom of our vulture. Yes, we're going to make sure the bottom of our ostrich is bigger than the top. Okay, this should work now. Hopefully. Okay. Checking for that left collision. Fuck. We really messed that up, didn't we? Just seeing if the left side of our ostrich is smaller than... God, yeah. See, this is smaller than this. The right is bigger than this. So we're seeing if the left side of our ostrich left side of our ostrich is bigger than the right side, and the right side of our ostrich needs to be bigger than the left side of our ostrich. Yep. Our ostrich bounding box, rather. And then, okay, let's see if that works. Come on, left collision. See, so we want less than this. You know, this shouldn't be a left collision, this might be a right collision. So we need to shift our bounding box to be smaller. So I guess if we do this to everyone, let's see if that looks a little bit better. Yeah, look at how much the top collision is triggered here, and my feet are basically on top. This is too high for the top collision detection, and the bottom collision isn't high enough. This needs to be, this should probably be, this should probably be a bottom collision too. And this should probably not be a top collision when we're right here. Right here probably should be a top collision. So let's shrink that. We're gonna shrink our top collides by seeing our top collides is just checking that. So we're seeing if the top of our ostrich X. We're seeing if the left of our ostrich is smaller than the right side of our enemy. We're seeing if the right side of our ostrich is bigger than the left side of the enemy. Then we're saying our ostrich is Y. The top of our ostrich needs to be smaller than the bottom. Yep. And the bottom of our ostrich, top colliding box, which it should be here, this one, bottom of that should be smaller than this one, bottom, bigger. So yeah, if the bottom of ours, top of our box is smaller than the bottom of their box, and the bottom of our box is bigger than the top of theirs. That's why. So I think if we leave this 4 and we take out this, our top colliding will be better. True. Yep, that's about what we want. Maybe a little bit more. I think that might be a true, but that's okay. So that's working. We need our bottom collides needs to be what, more sensitive or less sensitive? What was it? That's true. It needs to be, actually, yeah, that's about perfect. Yeah, that's perfect. Yep. So yeah, this would be so look, if we collide here, this would be a top collision, but if we collide here, it would be registered as a side collision, which, depending on which way they're facing, could still result in the same thing, but it depends on which way they're facing. So that's doing okay. Now, you know what? I kind of want, like, well, no, we'll do it. We'll do it just like this. Let's see if we can't get 4 functions implemented today, yeah? We need the enemy right collides. So I'm gonna, it really helps me to freaking diagram this out. So our enemy right collides function. We know it's a right collision. We're checking our right collision bounding box on our ostrich and our left on our vulture. That would trigger a right collision. So we're trying to see if the leftmost part of our ostrich, so we're going to say for self.x plus that inset for that bounding box, left side of our box is smaller than the right side of our vulture's bounding box, which would be enemy x plus its weird offset. And we're going to see if the right side of our ostrich, if our self.x plus self.width, the right side of our ostrich is smaller than, let's see, left side smaller than right side bigger than the left side. So the right side of our ostrich would need to be bigger than just the enemy's x. Then we need to check the y's, and we'll say if our ostrich's y would need to be smaller than, the top of our ostrich would need to be smaller than the enemy's y plus its height. So it would need to be top of our ostrich needs to be smaller than the bottom bounding box of our vulture, and the bottom of our ostrich self.y plus self.height, bottom of our ostrich needs to be bigger than the top of our ostrich. Okay. All those are true. You return true. Else return false. Now let's check. We gotta print up our right collides. Right collision, enemy, right collides with self. And now we'll see if we've got right collision. Look at that. Look at that. I think I'm noticing an error. So if you look at our butt, I can't zoom in because my position is controlled by the mouse, but our vulture's butt looks to be cutting off, and we're detecting a collision before our tips are touching. So that tells me I think we're just drawing the sprite wrong. Yeah, I think we're not setting the viewport right on this. Fuck. So hard to test that. Yeah, do we have to see, like, let's look at our vulture. Do we set a viewport? For spawning, we set the viewport. Let's look at wherever we set the viewport. 6 times. We do it when we're spawning, we do it when we're standing still, and we are offsetting this by 1. Let's check our vulture sprite to make sure we actually did that. Look at our joust source. Fix Vulture Atlas. Okay, this doesn't really help us. Oh, look, yeah, we didn't give ourselves, we gave us the buffer pixel at the end, so we actually should set our viewport here to 0. And then we have the offset of that extra pixel in the animation, so maybe that'll fix it. We're looking for only a right collision upon tips touching. So yeah, this was returning true earlier, but now only tips touching. Which actually, you know, it's hard to say that should even be a collision because they're not colliding, they're just like next to each other, but I'm happy with that. So yeah, and look at, we can't have, this makes me happy. See how we can't get a right and a left collision? Depending on the pixel, it's either going to be a right collision, one pixel over, left collision instead. But actually, that shouldn't be a left collision. This is a right, well, hold on. No, yeah, left collision should only be I think this is okay. It's not perfect, but it doesn't need to be perfect because we're resetting all these positions upon the detection of them. We just need to make sure we have the ability to trigger them. I do think our bottom collision needs a bit more height, but our top one is just about perfect. But I think they were the same, you know, offset by 4, right? Our bottom offset by 4, top offset by 4. So yeah, what if we do just, we give us a little more room to bottom collide so that we can be a little higher up and still trigger it. Bottom true. See, I feel like even that should maybe be a bottom collision. So if I do, does that get better? Does that make it one more pixel? True on a bottom. True on a bottom. Okay. Okay. I think that's okay. They're like a little bit arbitrary adjustments here, but I'm just trying to why is this +4 and not +8? That was in our left collision. Okay. Sweet. And it's okay. Yeah, I feel like we actually need 5 or 6 on that top. Let's just do 6 to be the same. Either we both go 5 or we both go 6, so leaning towards 6 right now, but yeah, perfect. So we can only trigger either a left or right, which is perfect. And we can, when we trigger both, like this is what was giving us all those problems. Because the just AABB collision would be like, yeah, you're colliding, but it doesn't tell you what to do, what logic to do differently. So like if we're top colliding and left colliding, we want to supersede, we want to prioritize the top collision. Just because that's what I'm deciding. And if we do that first, like we check for top or bottom collision first, do the appropriate logic there, then check sides. So as long as we're okay with this being a top collision, which I think so, and okay with this being a bottom collision, which I think so, then we've got everything we need. Heck yeah, bro. Heck yeah, bro. Okay. Sweet. Okay. This was huge. This was like the culmination of the past 3 episodes of just banging our heads, doing the same thing over and over, but we finally did something different, and now we have proper enemy collision detection. So now we can finally work on that logic and start implementing it, and then once we get the logic done, then we can work on fleshing out more stuff. Add eggs, add players, add those platform warping places, add the hatching eggs, yeah, all that good stuff. Score points, waves, all that good stuff. I'm happy with that. I'm gonna call that a good session because I think I'm just fried. We'll get add with a commit message saying all enemy collision bro, how do you spell collision? 1S? All enemy collision detection working. Now, I'm gonna key it up to our origin main. Cool. Cool. So yeah, we took out all that nastiness. We now have these handy dandy shrinkers for us to work on blocks of code and minimize blocks of code so we can read it easier. I'm feeling pretty good about it. So yeah. Yeah, I guess, so next on our list, here, let's update this thing. We have wow, look at this. This is all the little notes I've been adding since we started the stream. Let's just do 24. Yeah, so we did do this, which is good. Do that just yet. We did this, but yeah, we need temporary safety still. We need the flashy. God damn you. Okay. I'm just gonna hit. Okay. Which was the past 9 hours on stream, I guess, was this one thing. Okay, then we can work on that. Okay. Respawn portals, complete collides. Okay, yeah, we're good. Sweet. Okay, well. I guess tomorrow you know, first things we're gonna do, we're just, now that we've got the collision detection working, we're gonna loop through each enemy and do this stuff, which is a couple different things, but we've got that kind of well planned out already, because we tried implementing it already the past episode and just failed. It's all right here. So we see which way we're facing. See which way we're facing. And we can do this instead of doing this where we're like detecting if we're on the left or not. Now we use those functions where we say if left colliding, see what we're. I think the big nest in this code block is going to be check which way we're facing first. You check that first, and then the flowchart goes from based on what collision you are and what way you're facing. So it might be, it would probably, the flowchart probably goes collides first, top and bottom, then which way are you facing in those, and then it goes left and right, and then which way are you facing in those. But yeah, it shouldn't be too hard. Shouldn't be too hard for next time to get some of that working. And then it just feels good to be able to whip stuff out, you know, like I had that idea of wanting to draw a character at a mouse position so I could check these collisions. And I was able to implement that, not too hard, not too difficult. I'm really happy with that, because the only code we needed for that was this. Get our mouse X and Y, and then assign that into our ostrich. Cool. All right, well, this about wraps it up for today. I'll be back tomorrow for some more programming adventures. I'll see you guys. Have a good day.